Okay, so for part D, this part's difficult, guys. It says use the results from B and C. This is B and this is C. This is what we got. The area of one of these isosceles triangles is this, and y is equal to this. Show that A equals P equals 4n tan of pi over n, and it's 7 marks. Okay, so firstly, the total area, A, is equal to n of these, because this is the area of one of these isosceles triangles, and there is n isosceles triangles. So A, which is the total area of this polygon, is going to equal n times this. That's the first thing to get your head around. N over 2 x squared sine 2 pi over n. Second thing to consider is that P is going to equal n of these, because there's n y's for the perimeter. So that's going to be 2nx sine pi over n. Okay, next thing, we know that A equals P. We don't have to show that A equals P. We know A equals P because it says that at the start of the question in that bold writing. We said that we're studying these polygons that have A equals P, so we can use that. So let's write that down. A equals P. Therefore, this thing, n over 2 x squared sine 2 pi over n, equals this thing, 2nx sine of pi over n. Okay, a few things can cancel because we're going to solve this equation now, guys, basically, and find, well, we're going to find x, but x is not 0, x is definitely positive, so I can divide by x. So I'm going to divide by x here and get rid of that squared and get rid of this x, and I can get rid of this n and this n. So let me write it like this: x over 2. I'm dividing by nx. So x over 2 sine 2 pi over n equals, dividing by nx, 2 sine of pi over n. Now we're trying to find x ideally in terms of pi over n. So this is the first kind of, let's say, trick that I need to apply. This is, if you remember, the double angle formula. So I can actually write this because we're trying to find, okay, how do I know to do this? Well, I've got an equation with two different angles, but this is double this. So that's the first hint that it's the double angle identity. The second hint is I want to turn this all into tan, and in order to bring in a tan, I need a cos. And when I use the double angle identity for sine, that'll give me the that'll bring in a cos. So that's the second kind of hint. Anyway, I'm going to use the double angle identity for sine. That gives me x over 2 times, so the double identity is 2 sine pi over n cos pi over n. It's sine of 2 theta equals 2 sine theta cos theta, and this is equal to 2 sine of pi over n. Okay, now I need, okay, I have a 2 sine pi over n and a 2 sine pi over n, so they actually cancel. So I have an x over 2 cos pi over n equals 1, because this and this cancel like this. Then I can say x is equal to 2 multiply by 2 and divide by cos pi over n. So 2 over cos pi over n. Okay, that gives me x. Now, to find, I need to find either a or p. So I need to sub this x into p or into a. I don't have to do it into both because I know a is equal to p. I think the easier one to do is p, so I'm going to sub it into p. Therefore, p equals 2nx, which is 2 over cos pi over n. So that's my 2nx, and then sine of pi over n. Now remember what I said, guys, to bring in the cos will give me the tan, because look, this is tan. So this perimeter is equal to 2 times 2 is 4 n, and cos pi over n over, sorry, sine pi over n over cos pi over n is tan pi over n, which is what I want. Therefore, so if this is P, therefore A equals P equals 4n tan pi over n. Q, E, D. I've shown what they have asked. Okay, that's part D. 7 marks. Yeah, that was tricky.